Moving into chapter 5, we are going to start looking at quadratic functions. And for section 1, we are going to be transforming them or looking at different transformations. So a quadratic function is one that can be written in the form of f of x equals a times the quantity of x minus h squared plus k. And you also need to know that a cannot be 0 in this function. And also, you know it's a quadratic function because the variable is always squared in quadratic functions. A parabola is the name of the graph for a quadratic function, and a parabola is a U-shaped curve, and it can open up or down. And the parent function of quadratic functions is f of x equals x squared. So that's the simplest version of a quadratic function that you can get. So for example 1 here, they are asking us to graph f of x equals x squared minus 6x plus 8 using a table. So we are going to have to fill out a t-chart here, and we're going to plug in 1, 2, 3, 4, and 5. Normally I have you pick out -2, -1, 0, 1, and 2, but I know that this graph is more towards the positive x values. If we plug in some negatives, we're going to get some pretty large y values that aren't going to fit on the graph that I have for us. So in order to figure out our ordered pairs, we have to plug in each x value. So we're going to have to do 1 squared minus 6 times 1 plus 8. And for that, we get an answer of 3. Then we're going to plug in 2. So we're going to have to do 2 squared minus 6 times 2 plus 8. And for that, we'll get an answer of 0. And then 3 be 3 squared minus 6 times 3 plus 8. For that, we'll get an answer of -1. And 4 squared minus 6 times 4 plus 8 will give us an answer of 0. 5 squared minus 6 times 5 plus 8 would give us an answer of 3. So when you see this pattern here where the numbers are going to repeat, that's when you know that you have that U-shaped part of your graph where it comes down and then starts to go back up, or vice versa if it goes up and then starts to come back down, depending on how it's opening. And then our last part is just to plot those ordered pairs that we just came up with. So the first one is over 1 up 3, then over 2 up 0, over 3 and down 1, over 4 and up 0, and over 5 and up 3. And then you get a good picture for your U-shaped parabola there. All right, moving on, we have translations, and we have horizontal translations, we have vertical translations. So the blue is our parent function, the blue graph there of f of x equals x squared, and then the red is our translation. So in the first part here, we have horizontal shift, and that is h units. So the h value of our quadratic function gives us how far right or left that we move. So right here, if h is less than 0, it moves left, and if it is greater than 0, it moves right. You do have to keep in mind, though, that the formula is already a minus sign. So if you plug in a negative number, that's going to turn positive. So it's going to kind of be opposite of what you first see. And then looking at vertical shifts, the k value is what tells us about our vertical. And if k is less than 0, it's going to move down. And if k is greater than 0, it's going to slide it up. So we're going to take a look here using the graph f of x equals x squared as a guide. describe the transformations, and then graph the function. So we have to look at our equation and tell the transformations first. So I want you to remember the quadratic function was a times x minus h squared plus k. So we're going to look right here for our horizontal shift, and notice it's a minus h, and our function that they gave us is plus 3, so it turned into a positive. So in order to turn into a positive, we would have had to do x minus a negative 3. So our h value is a negative 3, and up here it told us moved left when h was less than 0. So this is moved left 3 units. And then our k value is what moves it up or down. And this one's a little bit simpler. You just look, it's plus 1, so that means up 1. And then we can graph our two functions. X squared, so just think about the ordered pairs. If we plugged 0 in, 0 squared would be 0, so we'd have an ordered pair of 0, 0. 1 squared would be 1, so we'd plug in 1, we'd get 1 for an answer. 2 squared would be 4, so we plugged in 2, we'd have an answer of 4. And the same thing for the negative numbers here. So this is our parent function. That's our f of x. And for our g of x, we are going to plug in some numbers for x plus 3 squared plus 1. We can do a t-table and plug in a few numbers, or we can look here at what we just figured out from that equation, moving it left 3 units and then up 1. So if I took every one of these points, so I'm starting at 0, 0, I'm going to move left 3, and then I'm going to go up 1. So that would move here. This one, I would move 1, 2, 3, and up 1. And then 1, 2, 3, and up 1. So I'm going to have to do that to every point. And then I have my new g of x graph. So I think that's a little bit easier than plugging in a number and making this t-chart over here, but that's always an option. But I think that takes a lot more time. All right, and then for this example here, remember going back, we had a x minus h squared plus k. So let's look at the h value. Remember our formula is subtraction, so we have a subtraction sign there. So our h value would be a 2. And if we go back to our chart, it says that if h is greater than 0, it moves right. So this one's going to move right 2 units. And then our k value is a minus 1, so that means down 1 unit. And then we have to graph. We're going to graph our parent function. Our parent function is 0, 0, 1, 1, 2, 4. Same thing on the other side with the negatives. So that's our f of x. Oops. And then we're going to have to graph our new parabola, right 2 units and down 1. So I'm going to start here, 1, 2, right, and down 1. 1, 2, and down 1. Do that for every point, and we have our new parabola. That is where we're going to stop. I will pick up for reflection, stretches, and compressions in the next video.